Hi everyone, this video is about elevators problem in physics. So imagine there is a person of mass m who is standing inside a lift. So for simplicity we are considering that the mass of the container of the lift is negligible. Only the person is having mass and the floor of the lift is strong enough, the rope is strong, the cage is strong, the container here is strong so that the person can be stationary inside the lift. Now let's consider a situation where the person is at rest inside the lift, and in this situation we are taking lift also at rest. So the elevator or the lift is at rest. When they both are at rest, you can say the weight of the person will act downward. So here is the weight of the person which is acting downward, and the weight is mg. And the reaction force which is applied by the floor is, let's say, R. So why the floor applies reaction force? So the reaction force is applied in response to the weight or in response to the force applied by the earth, and that is what the weight is. So weight is reaction force, and if lift is stationary and the person is also stationary, then we can say the net force acting on the person is 0. So F net equals to 0, and we can write here F net equals to reaction force minus mg, and as you already said, F net is equal to 0, so we can write R minus mg equals to 0. In this case we can write R equals to mg. It means reaction force is equal to the weight of the person, and this is the definition of the weight. Now let's come to second situation where the lift is going upward with an acceleration a and the mass of the person is m, we already know. So in this situation, when the lift goes upward with an acceleration a, the person will also go upward with an acceleration a because the person is standing on the floor of the lift. When the lift will go up, person will go up. So to take the person upward with an acceleration a, you can say the reaction force applied by the floor must be greater than the mg, which is the actual weight of the person. So reaction force must be greater than the mg. So here I can write R is greater than mg. This is the reaction force which is acting upward. So when reaction force is greater than mg, we can say there is net force upward, right? And if there is net force upward, we can write F net is equal to R minus mg, because the reaction force will be in the direction of R. From Newton's second law, you can say F is equal to ma. So ma, which is mass of the person, and the person is getting accelerated with an acceleration a, so you can write ma is equal to R minus mg. If you rewrite this equation, then it can be rearranged something like this: R is equal to mg plus ma, or R is equal to mg plus a, right? So here you can see that the net acceleration of the person is greater than the g. So the weight of the person, here instead of saying weight we can say the apparent weight, which is not real weight. So apparent weight of the person is greater than the actual weight. Okay, so here R greater than mg. Once again I am writing for simplicity and for understanding. Now let's come to the third situation where the person is going down with an acceleration a, and when the person is going down you can say the lift is also going down with an acceleration a, because they both are attached together. The person is standing on the floor of the lift, so they both have downward acceleration a. If the person is accelerating downward, then now you have to think a little bit here to understand clearly. Who is accelerating the person downward? So it's the mg that pulls the person downward, right? And if there is net acceleration downward, you can say mg, the weight of person, must be greater than the reaction force which is applied by the floor of the lift or the floor of the elevator. So if mg is greater than r, we can write that F net is acting downward, right? So if F net is acting downward, I can write F net equals to mg. Now in this case mg is greater than r, so we will write mg first and we will subtract r from it because r is acting opposite to mg. So in this case, from Newton's second law, the person is accelerating with acceleration a and the mass of the person is m. So we can write ma is equal to mg minus r. So if you rearrange this, you will get r is equal to mg minus ma. And in one more step, you can write r is equal to mg minus a. Correct? So the reaction force which is acting on the person is less than the actual weight. So we can say r is less than mg and r is responsible for the weight. So we can say the apparent weight of the person is less than actual weight. So that's it for this video. I hope you understood. Continue revising.